Today I will be showing you how to solve a College Board AP Chemistry free response question. The question I will answer is question number 3 from 1992, parts A through D. The question starts with the equation Cl2 plus 3F2 produces 2ClF3 and states ClF3 can be prepared by the reaction represented by the equation above. For ClF3, the standard enthalpy of formation delta HF is negative 163.2 kilojoules per mole, and the standard free energy of formation delta GF is negative 123 kilojoules per mole. Part A asks you to calculate the value of the equilibrium constant K for the reaction at 298 Kelvin. First, we need to change our standard free energy of formation into the standard free energy of the whole reaction by using the equation delta G equals delta G sum of the products minus delta G sum of the reactants. And since both of the reactants are pure gases, we only need to multiply the negative 123 kilojoules per mole by the 2 moles of the product ClF3 to get negative 246 kilojoules per mole. Next, using the equation delta G equals negative RT natural log of K, we can rearrange it to solve for K after we plug in the temperature, 298 Kelvin, the gas constant R, 0.008314 kilojoules per mole Kelvin, and the standard free energy given to us, negative 246 kilojoules per mole. If we divide negative 246 by the gas constant and temperature, we can get the natural log of K by itself and find that the natural log of K is equal to 99.29. To get K by itself, we can raise E by both sides of the equation and solve to get K equal to 1.32 times 10 to the 43rd. Part B asks you to calculate the standard entropy change, delta S, for the reaction at 298 Kelvin and starts off much like Part A, except instead of solving for delta G, we will solve for delta H. Once we have the delta H for the reaction, we can plug into and rearrange the Gibbs free energy equation to solve for delta S. After plugging in and rearranging, we find that delta S is equal to negative 0.270 kilojoules per Kelvin, or negative 270 joules per Kelvin. Part C asks, if ClF3 were produced as a liquid rather than as a gas, how would the sign and the magnitude of delta S for the reaction be affected? Explain. I said that the sign of ClF3 would remain negative, however, the magnitude would be greater due to the reaction becoming more ordered. This means that delta S would be a larger negative number as a liquid than it is as a gas. Part D has 2 parts and begins by stating that at 298 Kelvin, the absolute entropies of Cl2 and ClF3 are 222.96 joules per mole Kelvin and 281.5 joules per mole Kelvin respectively. The first part of D asks you to account for the larger entropy of ClF3 relative to that of Cl2. I said that ClF3 has a larger entropy than Cl2 due to it having a greater number of atoms and a more complex structure. Part 2 of D asks for you to calculate the value of the absolute entropy of F2 at 298 Kelvin. Using a similar equation as in parts A and B, we can solve for delta S, although this time we will have both products and reactants. To solve for the absolute entropy of F2, one of the reactants, we will have to rearrange the equation after plugging in the delta S calculated back in part B and the absolute entropies given to us now in part D. After plugging in and rearranging, we find that the absolute entropy of F2 will be equal to 203.35 joules per mole Kelvin. Thank you for watching. This ends the 1992 question 3 free response on the AP Chemistry College Board test.